Now we're going to be looking at the quotient rule for exponents. Now the quotient rule is very much related with the product rule. Let's write the product rule here again. Product rule says that if we are multiplying two expressions of the same base, then we can just simply add those two exponents. Now the product rule was fairly simple because it just shows us the relationship of multiplication and how that leads to the addition of the exponents. And product rule is actually a bit more simpler than the quotient rule because even though the orders become different here, the result would be the same because both multiplication and addition are commutative. That's the same thing as saying x to the a plus b. Now for quotient rule, it follows the same process. So let's say we have 2 to the 5th power divided by 2 to the 3rd power. Now that would equal, let's rewrite this as a fraction because all division problems can be rewritten as fractions. 2 to the 5th power goes on top. So we have 5 2's on top. And we have 3 2's on the bottom. Now from elementary school, we know that if we have the same term being multiplied to both the numerator and the denominator, we can cancel those. So we can cancel a pair of 2's here. We can cancel another pair of 2's here. And another pair of 2's here. And that is going to equal 2 times 2 or 2 squared. And if you notice, our answer here is 2 squared. How did we get 2, the exponent 2, from an exponent of 5 and 3? And we got there by subtracting 3 from 5 to get 2. Now this seems reasonable because for product rule we were multiplying and that led to the addition of exponents. And for the quotient rule we have division of the terms and that leads to the subtraction of the exponents. Now one more complicated step about quotient rule is that if the orders were switched here, we don't get the same answer because division and subtraction are not commutative as opposed to multiplication and addition. Let's see what we get if we do 2 to 2 cubed divided by 2 to the 5th power. Let's do the same thing. But this time we have 3 2's on the top and 5 2's on the bottom. Let me erase this here so that we have enough space. And we can again cancel the 2's. But this time we get 2 2's in the denominator, not on the numerator. So this does not equal 2 times 2, but indeed it equals 1 over 2 times 2. We need to notify that the 2 2's are on the bottom, not on the top. And that is going to equal 1 over 2 squared. So we got the same number, but this time it was in the denominator. So whenever we have a smaller exponent minus a bigger exponent, our answer is going to be 1 over the subtraction of those exponents. Now, if you are comfortable with negative exponents, this is going to make sense because we can do the same thing. 2 cubed divided by 2 to the 5th power. That is going to equal 2 to the power of 3 minus 5. And that is going to equal 2 to the negative 2. And that is the same as 1 over 2 squared. But not a lot of people are comfortable with negative exponents and negative numbers in general. So sometimes it could be easier to write the process like this as a fraction. And you can see that the leftover is going to be on the denominator when our first term has a smaller exponent. So the general rule for quotient rule, let me write the quotient rule down here. There's going to be two cases. Say we're dividing x to the power of a divided by x to the power of b. If a is bigger than b, we can just go ahead and subtract b from a. So that is going to equal x to the power of a minus b. However, if b is bigger than a, we are going to get 1 over x to the power of b minus a. So we are still subtracting the smaller exponent from the bigger exponent. But because here the first term has a smaller exponent, it's going to be a fraction where the remainder, or the remaining terms that are not being cancelled, is going to be in the denominator. Now in general, if a is bigger, in this case, the answers are going to be bigger than 1. Answers are bigger than 1. And if a is smaller, answers are going to be less than 1. And you can see that with our fractions here. If a is bigger, x is going to be raised to some positive exponent, so that's going to be bigger than 1. In our case here, x is going to be raised to some positive exponent, but it's going to be 1 over that, so it's going to be less than 1. And this is assuming that x is a positive number. So you can think of this as the absolute value being bigger than 1 and less than 1. But for simplicity's sake, we are assuming that x is a positive number. And if it is, then in general, our answers are going to be like this. So if you got a question like 2 to the power of 4 divided by 2 to the power of 6, and if you got that the answer was 2 squared, you can know that you did something wrong because our a is smaller than b, and you should get an answer that's less than 1. But here you got an answer that's bigger than 1. So that means you made an error somewhere. And in fact, if you double check, you can see that it has to be 1 over 2 squared. So then this would be the correct answer. So that's a rough way to check if you've done your calculation correctly. So this right here is the quotient rule. It's a little bit more complicated than the product rule, but with more practice, I'm sure you'll be very familiar with it. Now, one last thing that I would like to go over. There's a special case with the quotient rule, and that is what happens if a equals b. In this case, let's bring this case over here. If a equals b, so that means we're going to have the same number divided by the same number. And if you remember from elementary school, whenever you divide the same number by the same number, for example, 2 divided by 2, 3 divided by 3, 10 divided by 10, you always get 1. And this is going to be the same here. You're dividing the same number by the same number, so you're going to get 1. And following the quotient rule, you can also see that if you follow the quotient rule, x to the a divided by x to the a is going to equal x to the a minus a, and that is going to equal x to the power of 0. Now, we know that anything to the power of 0 is going to equal 1. So if you follow the quotient rule, you'll still get the same answer as you will if you follow the concept you've learned in arithmetic. So if a equals b, or if you're dividing the same term by the same term, it will always equal 1.